The equilibrium equations provide both necessary and sufficient conditions for equilibrium. Not all structure can be solved strictly from the equations of equilibrium. In this video, we will discuss determinacy and indeterminacy of structures. A structure is said to be statically determinate when all the forces in the structure can be determined strictly from the equations of equilibrium. A structure can be identified as being statically determinate or indeterminate by drawing the free body diagram of all its members. For 2D structure, there are at most 3 equations of equilibrium for each member, with the exception of 2 force members. If R denotes the number of force and moment reactions and N denotes the number of members, the product of 3 and N is the number of equilibrium equations for a particular structure. We can check for the determinacy of a structure using this equation. A structure is said to be statically indeterminate if the conditions of equilibrium are not sufficient to determine the total reaction of the structure. Degree of indeterminacy. Degree of indeterminacy of a structure is the difference between the total unknown reaction and the number of equilibrium equations. For statically determinate structure, the difference is equal to 0. For statically indeterminate structure, the difference is greater than 0. And if the difference is less than 0, the structure is said to be unstable. For better understanding, let's take a look at some examples. You have to check if these structures are statically determinate or indeterminate, given that some known external load can act anywhere on the structure. To check for the determinacy of this structure, first, we draw the free body diagram, showing all the forces acting on the member. Then, we count the number of force and moment reaction on the structure. 2 reactions from the pin at A, 1 from the roller at B, and N is equals to 1. Then we check for the determinacy of the structure using this equation, which gives, therefore, the structure is statically determinate. For this structure, we will draw the free body diagram, showing all the forces acting on the members. Then we count the number of members and unknown reaction of the structure, 5 external reactions and 2 internal reactions at C. Note, the reaction at C is 2 because the reaction experienced by both members at C are equal in magnitude but opposite in direction, and N is equals to 2. Then we check for the determinacy of the structure, which gives, therefore, the structure is statically indeterminate, with degree of indeterminacy of 1. For this structure, we will disassemble the frame, showing all the forces acting on each members. Both members can be identified as 2 force members, but known external load can act anywhere on the structure. So there are 3 equations of equilibrium for each member. Then we count the number of members and unknown reaction of the structure, 4 external reactions, 2 internal reactions at A. Note, the reaction at A is 2 because the reaction experienced by both members at A are equal in magnitude but opposite in direction, and N is equals to 2. Then we check for the determinacy of the structure, which gives, therefore, the structure is statically determinate. Thanks for watching. If you like this video, give it a thumbs up and subscribe to the channel.